Section 1.6 is subtracting integers. Now what we're going to do is we're going to build off from section 1.5 where we were adding integers. We're going to use a lot of those same rules because as you're going to see, they're very closely related. Now I want you to look at the first two examples that I have here. I have 6 minus 2 and I have 6 plus negative 2. They look like two different problems. Now what I'm going to do is I'm going to show you both of these problems on the number line. 6 minus 2, you're at 6, and then you come back 2, piece of cake, you're at 4. We already knew that way in advance. 6 plus negative 2, using the number line again, I'm going to start at 0, I'm going to go to 6, and a negative 2 means to the left, so I'm going to come back to the left, and I'm at 4 again. Now we know that when you add a positive and a negative, you are going to subtract the absolute value of the smaller from the absolute value of the larger, whichever one has the larger and smaller absolute values. So 6 minus 2 is 4, and then you're going to take the sign of the add-in in which has the greater absolute value, which is 6, so that's why it's a positive. We get the same answer. The problems are very closely related, and that comes from this definition right here. To subtract an integer, you add its opposite. This causes students all sorts of concern, but if you remember that adding its opposite is the same as subtraction, you're going to have a lot more success working these problems out. Now, I'm not talking about this type of a problem, a traditional subtraction problem, where you have a larger positive number minus a smaller positive number. I'm talking about what I call non-traditional subtraction problems, not the kind of subtraction problems that you would have seen in grade school. And I have 4 examples right here. I'm going to work each one of these problems by adding its opposite. So the very first problem I'm going to do here, 11 minus 15 is the same as 11 plus negative 15. Notice how I leave the first number the same, I change the subtraction sign to addition, and I take the opposite of the second number. That's the adding the opposite part. Some people call this keep change opposite. Keep the first number the same, change the subtraction to addition, take the opposite of the second number. And now I'm going to apply my rules for addition. I'm adding a positive and a negative, just like I was doing a moment ago with 6 plus negative 2. I'm going to take their absolute values, subtract the smaller from the larger. 15 minus 11 is 4. Since the larger absolute value comes from the negative number, I'm going to have as my answer negative 4. Right over here, I have a non-traditional subtraction problem. I'm going to change that to 8 plus a positive 9. Notice again, keep change opposite. You keep the first number the same, change subtraction to addition, and take the opposite of the second number. Of course, the opposite of negative 9 is 9. Now it's just a simple addition problem, 17. The next problem, more of the same, a non-traditional subtraction. I'm going to write this as negative 13 plus the opposite, negative 2. Now I'm adding two negative numbers together, and we know that when we add numbers with the same sign, we add their absolute values. 13 and 2 is 15, and we keep the sign. So this will be a negative 15. Again, we're changing weird-looking subtraction problems into more traditional-looking addition problems, and using the rules that we learned in addition from the last section. Negative 2 minus a negative 9, the last one here, is the same as negative 2 plus the opposite of negative 9, which is a positive 9. And here again, one of each. This is the tricky one. When you're adding a positive and a negative, you subtract their absolute values. 9 minus 2 is 7, and you take the sign of the one with the greater absolute value. I have more positive than I have negative. Remember I talked about this like money. I have $9, I owe $2. I'm going to have a positive $7 because I have more money than what I owe. And it's a positive 7. Now I'm going to apply the algebra and set these up as expressions where we substitute in. You can see I have some examples below here. I'm going to take the negative 7. I'm going to substitute it right in there. So the first thing I'm going to do is write this as negative 7. I guess I can go ahead and put the parenthesis. I don't really need it. Negative 7 minus 6. This is the same as negative 7 plus negative 6. Notice how I keep change opposite. Now I'm adding two negatives. I add them up like they were positives. I take their absolute values and combine. That's 13. And since I am adding two negatives, my answer is a negative 13. Keep the sign of the values. Over here, I'm going to substitute in. I get negative 7 minus a negative 15. This is where I'm going to change it into an addition problem. Negative 7 plus a positive 15, adding the opposite. One of each. subtract their absolute values, take the sign of the larger, I'm going to have a positive 8. Negative 9 minus a, substitute the negative 7 in here. Now I'm definitely going to put the parentheses, minus a negative 7. Negative 9 minus a negative 7 is the same thing. I'm going to change it to an addition problem by the definition as negative 9 plus 7, one of each. A positive and a negative, you subtract their absolute values, take the sign of the larger, I'm going to have a negative 2. Now what some teachers show is that when you have this subtracting negative written this way, a lot of teachers will show, we'll just connect the subtraction and the negative sign and it looks like a plus sign. And that's a little shortcut that you can use. The last one here, I'm going to substitute the negative 7 in here, negative 7 minus 10, which of course is negative 7 plus negative 10. Adding two negatives, like I did, where did I add two negatives before? Back here, you add them up as if they were positive, adding their absolute value, 17, keep the sign, negative 17. Oops. Negative 17 being the answer there. Of course, one application of subtraction has to do with finding differences in temperatures, differences in elevations. Anytime you ask how much more or how much less something might be, you're subtracting. So what we're going to do is we're going to use the rules for subtraction, work a few examples of application kinds of problems here. The first one has to do with elevation, and then there's some with temperature. Mount Everest is 29,032 feet tall above sea level, and Death Valley is 257 feet below sea level. What is the difference in elevation? Sorry, that's such poor writing there. What is the difference in elevation? Well, the difference in elevation would be subtracting 29,032 minus, now since this is below sea level here, this is going to be considered a negative, negative 257. I'm going to rewrite this as an addition problem, an equivalent addition problem by adding the opposite. And now it's a simple problem. I'm going to go ahead and just kind of do a little scratch work right here so I don't mess up. And I get 29,289, and this would be in feet. That would be the difference in elevations. The next three problems are all very similar. You're to find the change in temperature from one temperature to another temperature. You take the second one, you subtract the first one. You take the 2, you subtract the from. So this becomes negative 12 minus 7. This one becomes negative 15 minus a negative 9. And this last problem becomes 19 minus a negative 2. Well, again, I have these non-traditional subtraction problems. I'm going to change them to addition by adding the opposite. This becomes negative 12 plus a negative 7, or a negative 19 degrees Fahrenheit. So it dropped down because it's negative. This one becomes negative 15, adding the opposite, plus 9, one of each. Subtract their absolute values, take the sign of the larger. I'm going to have negative 6 degrees Fahrenheit. So again, a drop in temperature of 6 degrees. And this last one, this is 19 plus a positive 2, or 21 degrees Celsius, which would mean an increase of 21 degrees. You can see the applications, and you'll need to make sure that you know your rules for subtracting integers as well as you know your rules for adding integers, because they're so closely related. And that, of course, takes practice, practice, practice.